Alright, now we are doing the second part of introduction to sets from two program, which they will set operations. So here we have union of the set, the intersection of sets, complement of the set, and difference of sets, or the difference between sets. So we start with the first one, 2.1. Union union of sets. What is union of set? Union of two or more sets is just the combination of all of the elements of the sets into one set. So what do I mean? If you have one set that has Monday, Tuesday, Wednesday, and another set that has Thursday, Friday, Saturday, and Sunday, the union of both is just Monday through Friday. It is just So, for example, we have set A 1, 2, 3. Set B 4, 5, 6. What is A and B? A and B is going to be 1, 2, 3, 4, 5, 6. If you have everything, another example. C 1, 2, 3, 4, 5. And G 1, 2, 5, 7, 9. All the A and B is watch out, this is not you. It's not you. It is you and this. The inner side. So what will be A and B here? A and B is just. Make sure I don't copy back the one. If one and is here and one is here, copy that one time. Now I don't two times. Say I have one, right here 2, right here 3, right here 4, right here 5. I check online, there's no number that I have married. If there is no number that I have married to, 1 there is only already, 3 is 3 already, 5 is 5 already, 7 write it, and 9. Spaghetti the me that deep water so that you are busy. Number. Okay, put the GB chip. And that would be A and B. That's for the union of the sets. We see that home. So we can go to properties. Some properties of union. Properties of union. So for the properties of union, we have property 1 and A and B is equal to B and A. A and B equal B and A. So whether it means the which form they are the same as the first property, I don't think we need to prove it is logically correct. The second property says well, there's one example of this first property. Let's do an example. There's one example to see the DCC. If you have an A 1, 3, 5, 7, 11, 13. I have a B as 1, 2, and again. 2, 4, 60. What is A on B? A on B is going to be every time that is here and that is here also. Down 1. What table? Wait, table taking power exam. In A is 1, you use 0 and yes. In A is P, right? Your 3. Okay. Our legs are right taking so. Increasing all that. I'm seeing 2 here. Arrangement 2. I'm seeing 3 here. I'm seeing 4 here. Arrangement 4. I'm seeing 5 here. Arrangement 5. I'm seeing 6 here. Arrangement 6. So I'm seeing 7 here. Arrangement 7. I'm seeing 8 here. Arrangement 8. I'm seeing 11 here. Alright. I'm seeing 13 here. So I prefer to write it in increasing order, ascending order. You can write periodic order as far as all the terms are represented once in the linear. It is correct. So when is A uni? And this will just be because B and A. Oh, dear. They couldn't just the same thing. If that's for A and B, do this. Actually, you have to add it. If the answer for B and A, C, the same, no, that's what it's so. Going to have the same. So what is the next property? You have the identity property. So A union and then set is going to give you all the A. Put it to the height map A.
Yes, me really.
How did they mark up? What was that first property? What's the was that? Using another people have no shit. No, so okay, come is that to deeper by the specific. But the commutativity. This is identity. The next. Okay, is the identity property. We paid back A minion and then set equal A. As of an example, we only set A which is equal to 1, 2, 3. Or we have another set S. S is equal to an empty set. We see that if you have it in the assource for A on S, I'm going to go these values inside A plus the values inside S. So A on S, this is union W. It's A on S is going to be equal to prior 1, 2, and 3. This means there's no values. Yeah. So if you replace 0, you use 0 the same way, same thing. So A on an empty set is the original set. So the other property is the independent property, not the fully follows the validity property. Next, we're doing the independent property. So what does this case? It is going is beneficial. Then put it. So what does it state? It says A and A is the set A. So there is set A which is equal to another set A. The union of the two sets is normally going to be equal to A. Making an example, we have a set A which is 1, 2, 3. When another set A which is equal to the same 1, 2, 3. It's A and to put A and the same A is going to be the same master plate. Because there's no different 10 and there's no 10 bars added. 1, 2, 3 is same like 1, 3, 2. It's not in the same order, but the same elements are there. So if you do the union, you have the same elements, adding the same elements, so it will result in the same elements. So that was it. The fourth property. Let me write something and half, but this is equal to universal set. This is the universal set. It's called universal set. You should not forget it. So the fourth and last property of union is universal set property. So what does it state? It says that A union the universal set was equal to that same universal set. That's what it states. So for example, if you have e.g. if our universal set is 1, 2, 3, 4, 5, and A is equal to 1, 2. What would this mean? Okay, union this is equal to what? 1 is already here and 2 is already here. So we are just starting out of this. And if you add all of this to 1 and 2, which is already this, you will see that it is just going to be the same elements which are already the universal set. 1, 2, 3, 4, 5. So at least this here is equal to A or antitheta. How universal sets. So that's all for you. That is all for the explore. Union of the set. Remember here. So the next one is intersection of set. So what is the intersection? How will you define it? The intersection, you will say okay. If you have K intersection, beta is a sign of intersection, like an end. Means we take values of A that are common to A and B, like values of A that are common to both A and B. That will be the intersection in it. So for example, we have and this is called A intersection B. For example, we have they set A equal to 1, 2, 3, 4, and they set B equal 3, 4, 5, 6. What is A intersection needle? A intersection V is all of the sets that A also. So what are the sets that A? That also B. First check A. One is in A. Is one in B? No, one is not in B, so it is not part of it. 2 is in A. Is 2 in B? No, 2 is not in this B. 3 is in A. Is 3 in B? Yes. We have 3 in B, K. So write out 3 because there's 3 in A and B. 4 is in A, is 4 in B. Yes, write out top. And that is all. 5 is in B, there's no 5 there. 6 is in B, there's no 5 there. There's no 6 there. So that is A intersection B like that. Let's take another example. So we have A. Another example, we have A as A is equal to 2, 4, 6, 8. And B is equal to 1, 3, 5, 7. So what will be K intersection B? A intersection B, as we said before, is all of the terms that are in A that are also found in B. So what are the terms found in A and B? 2. Let's start with 2. Is 2 is in A, is 2 in B? No, 2 is not. 4 is in A, is 4 in B? No, it is not. 6 is in A, is 7 in B? No. 8 is in A, is 8 in B? No. You can do same for all of these values, you see that they are not the same. So you say that the intersection is an empty set. We can answer like that, either like this or good in all set there is. Okay, that's what it's going to be. So A doesn't intersection B is in all set. Let's take one last example. Let's take one last example. We have A as plus A football and B as students who play basketball. So what is A intersection B? A intersection B is students who play football and students who play basketball. So we also need to take football and also need to play basketball. How do we get their intersection? So the intersection of these two is students who play football and also play basketball. So that is just what you are going to write. Students who play football and basketball. That's A intersection B like that. Yeah. So let's see now what is a now you know what the intersection is. Let's see now what are joint sets. Yes. Okay. Yes. What are the joint sets? Look at this joint. Sets. These are sets which have no term in common. Which have a null intersection, which have no term in common. For example, we have a set A equal 1, 2, 3. Set B equal 4, 5, 6. If set A intersection B is a null set, then A and B are disjoint sets. That's joint 6. So this is for disjoint set. And dual is disjoint set. Those are rare tests which they can ask in the exam. What is a disjoint set? You will have to answer it. So now properties of intersection too. The first property is commutativity. What does this mean? A intersection B intersection B is equal to B intersection A. So for instance, if we have 1, 2 as A, is our D. I'm supposed to be it. Double of A has 1, 2, 3 simply and now Z parts 2, 3, 4. Our A intersection B is equal to, let's check what is it, A that I D. 1 is it is 1 in B? No, so you don't write it. 2 is 2 in B, yes, so you write it. 3 is 3 in D, yes, so you write it. A intersection B is 2 and 3. Let's check and see if it is the same like B intersection A. So, B intersection A, what is it? Let's check what values in B, which are also in A. So in B, I can find 2. Can I find 2 in A? Yes. So I write it 2. In B, I can find 3. Can I find 3 in A? Yes, I write it 3. In B, I can find 4. Can I find 4 in A? No. Well, close it. Close it because I'm ready. It's already. Or I've already gone through all the elements in me. So from here, I can see that A intersection B is the same like B intersection. So then this is for the first property. It's called a commutative property. The second one is identity with universal set. The identity property. So we have second property says, what you say? A intersection the universal set is equal to A. A intersection universal set is equal to A. For instance, let's do an example. Let our universal set be equal to the base of the week. So this is all the base of the week. And let A be equal to the name equals Sunday. Okay. So A is equal to Sunday, and then we have the whole set. So let's try and see A intersection E. What is A intersection E? A intersection and see zeta. Zeta. Okay. This is zeta. So any intersection zeta or A intersection in the lesser set, it is going to be, we check the values of A which are also in the lesser set. In A we have Sunday. Is there Sunday here? Yeah, there's Sunday. So in an intersection, you write, see, Sunday is nothing else in A, so there can be nothing else in A intersection. So you see A intersection B is equal to Sunday, which is equal to A. Just like our rule says. You see. See, that's what the rule says, and it is true. So, this is the next property